All right, hi again. Up until now, we've been talking about using the drawing object in Howler in the new API, and that's all good. But sometimes you want to access pixel data, and there's a couple new ways you can do that. So one is to use the new um, Howler image object, and let's take a look at that. So here we have a little plugin that just basically takes the value of an image and then maps the value to the hue. Um, we did this with there's a nice little HSV function in the VB color object, but COM, which the Howler interface is based on, COM was not really designed to do millions of things like in a loop. It's just it doesn't have that kind of performance. It's like a messaging system, and it's just it would probably fill up the messaging queue or something to that effect too much to call it millions of times. So what we did here was we just did a lookup table. We built a lookup table with all the possible values, which is only 1 to 255 or 0 to 255. So that's a lot less than say a million. And we just use this color object called HSV, and for every possible value, um, we mapped the value into a hue. We did that basically by dividing n is 0 to 255 by 255. So it's the value to 0 to 1, and then we multiplied it by 360. So that's 360 degrees of hue. And we put that in a lookup table. And then we loaded the image from Howler. We applied the lookup table to the value of the object. We didn't just use the average value. We calculated the luminance, which is sort of a weighted value, and then we just put it back in the image and send it back to Howler. All right, so let's take a brief look at this Howler object, this Howler image object, and I'll just start fresh here. Let's all right. You got the image. You can see some of the functions that are in there. There's conveniently there's a get image size function. We're going to want that, and we give it the parameters width and heights. This is two variables we want to. It'll actually return the value in these two variables. So we want to dim these as long, I believe it is, before we call that. Yes, and then we should have our image size. And at this point, we want a Howler image, which we've already created. We want to get a copy of the picture that we have here. Let's do that with, let's see, there's a couple different functions we can do this with, but let's use get pixels. And it takes a pointer to or it takes a buffer, basically, and it fills it out with the pixels in our image. So let's put buff here. There's a couple parameters here we can see what those are. It's use alpha, put false there, it defaults to false. These are optional parameters. And there's a format string. This is an interesting one. It's basically literally a string like RGB A, or it could be BGRA, or it could be ARGB, or something, any combination of those letters. And that is basically the order that we're going to get the pixel values. I'll just stick with the default value, so I won't specify that. We do have to dimension this array that we're using, so we'll go to dim buff as byte, and we'll redimension it. The width -1, height -1. No longer, formerly we had a padding on our images. We no longer have that padding when we use this. When we use these functions here, we don't have to worry about the padding. It's just literally the correct size. So let's see. not sure. Oh, I forgot to specify that. All right. Redimensions that to the correct size. Let's see what we call. I want get pixels, not set pixels. All right, so we should now have that a copy of that image. Let's do a for next loop. Y equals 0 to height minus 1, or x equals 0 to width minus 1. And I'll do it next while I'm thinking about it. All right, so what we want to do to read these values is we want to multiply the index by 4 because this is these values are stored. Oh, this is another thing we need to do. These values are stored 4 at a time, so we need to multiply the dimension by 4 and then subtract 1. Because remember, in VB dimensions, when you dimension an array, it's the upper dimension. It's not the actual size. So you have to subtract 1 from it. Okay. So now that we've done that, we can go ahead and read these. So buffer x, let's see, x times 4, comma y, g equals buffer 1 plus x times 4, comma y, b equals buff 2 plus x times 4, comma y. And you get the gag here. Is the pixels are packed into this array of bytes. So now that we have the images, let's do something. We'll just make them negative. That's real simple. But you can do really anything you want to at this point. Then we'll just put them back into the and that's about the gist of it. Now we just have to refresh the screen. Should have been a refresh there. Actually, I believe there's a refresh in this iObject too, so we'll use that one. And let's see, that should be it. I might have made a mistake or two, but that should be it. Let's see, did I mix something up? Oh, there we go again. Like I said before, for some reason, when you're in this development environment, it likes its own personal copy of Howler. It doesn't want to use the one you have open. But once you compile this, it won't act like that again. So we'll just go ahead and use this copy here. A little bit of a hassle. Not much you can do about it, probably. Let's see. And we're back. All right, let's see. Let's load an image in here of some sort, or we'll just run some noise of some sort. Okay. Should invert that. Whoops, overflow. What did we do wrong? Equals R. Let's see. R equals. Well, it's supposed to be negative R, not negative 1. G. Boy, you can't type and talk at the same time, I guess. It should be 255 minus, by the way, not negative. Anyways. Alright, so what happened? Overflow again, huh? Not entirely sure what's happening here. Okay, that time. Oh, one thing we haven't done is send this back. I dot set RGB